Hello everyone, on this video I'm going to continue talking about estimating a time series model using Stata. So in the second part of this do file, I'm going to show you how to estimate an ARP model, autoregressive model of degree P, and an ADL PQ, which is an autoregressive distributed lag model of order PQ. So I chose inflation, but you can repeat this part using the other two variables. So one of the very important questions in time series is what is the degree of an AR model? In other words, how many lags I need to include in order to forecast inflation or to forecast the variable. Does the variable inflation today depends on only the last quarter or the last 2 quarters or the last 3 quarters or the last year or the last 5 years and so on? So in order to answer this question, one of the very important tools that we use is the information criteria. And the information criteria is simply made out of the sum of the squared residuals. So the smallest, the better. The smaller sum of the squared errors in the model, the better is the model. So it's our main tool for measure of fit. In order to perform information criteria, we basically estimate the model in different formats. We do like AR4, AR3, AR2, AR1. In other words, we start from big to small. You can go up to AR5 or AR7, but I always prefer to start with AR4 model, especially that I don't have a large number of observations. I have 187 in this model. So I prefer to, and again, we are working with de-inflation, not just inflation, so we are losing one lag already. So we don't want to have large number of lags because the impact of losing degrees of freedom would be large on such a small model. So to do that, we start big to small. By default, people usually start with 4 if the number of observations are not large, but it's not a rule. So we start by, let's say, estimating this model. I'm sorry, so I need first to generate I didn't run this part because it's the part related to performing DF test manually. It's an optional part, but let me just make sure I have these variables. And using these variables, how the first difference in inflation depends on its own lags. And this is the very important part that we need to check, the value of AIC and the value of BIC. It's optional to choose either AIC or BIC. If you prefer to have a smaller model, you go with the BIC because the BIC has a larger penalty and would make you stop earlier in the model. If you don't mind about like adding an additional lag, then you usually go with the AIC. However, in many models, they would match. They would tell you the same degree of AR model. With the AIC, given that the equation used in Stata has a -2 before the likelihood function, this would imply that I might get at many times a negative value in the AIC in Stata. The formula I gave in class is just an equivalent formula where it doesn't have a negative value. But if I take the first difference of the equation, the square term would go down and the constant -2 would have an effect on the numbers here in AIC and BIC. And you can refer to courseworks where I have helpful reference on the exact equation used in Stata. But the good news is we don't worry about the negative. It's because of the constant term in the equation itself, and the more negative the better in our decision on which model to choose. Okay, so we have just run AR4 we would compare it with AR3, right? AR3, AR2, AR1, and each time we are kind of reporting these two. So let's go with AIC just to make it easier for now. So I'm going to compare AIC here. This is an AR1 model versus the AIC here, right? So this one is actually better. It's smaller. Keep going. This one is larger, right? And this is the AR4, it's 4.4. So let's go back, 4.4 versus 5.3, 5.8. So this basically means that AR2 model for inflation is the best because it has the largest negative AIC. And actually, if you compare the VIC in the three models, you would get the same answer. Okay, 2.7, 4.0, 4.9, 3.8. So 4.9 is the largest negative. So based on both AIC and BIC, our degree is actually, why did I say this is supposed to be 2? Okay, because it has the largest smaller AIC or BIC. Okay, next we are going to use this use this model and build on it. So by now we already understand that AR2 is the best out of all. Next, we're going to build on it and add the lags of unemployment. So it's basically the Phillips curve, right? So we're going to generate the lags of the first difference in unemployment, and we are going to use it and to check what is the degree of ADLPQ. For now, we already understand that our best P is 2, right? So if I start with this model, I should say actually I should have started with 2 right away, but okay, let me do it, and this is gonna confirm the result anyways. But if you're repeating this do file, you can actually start with 2, so you can start from this model, okay, because we have already found that 2 is the best for inflation, and then you can start with the 4 of unemployment. But in any case, it's gonna be also confirmed. So and this is a very important note, which is basically saying ADLPQ, you can choose the lags of Y, which is lags of inflation in our case, by BIC or AIC, okay? And decide on whether or not to include X, which is unemployment in our case, and this is by Granger causality. So this is what usually people do. So they would decide on this part based on AIC or BIC, and once they get it, as we already did here, you would just decide about this part using Granger causality. Okay? So, so let's start here. Again, I'm just gonna change this. So ADL 2, 4, and I don't need this part actually, because I already decided that 2 is the best, okay? Just gonna change something. So based on the ARP model, AR2 is the best model, so we will start with ADL2 and then Q, we have no idea. We're going to test it, okay? And so this is an important note, okay? And then now let's start by estimating a different model, starting with ADL24, because anyways we will start from big to small. So let's start with 4 and test it based on, okay, let's do it with AIC. Okay, so sorry, I'm just changing things. Okay, so let's start from big to small, okay, using IC. So this one is telling us -1593. How about this one? Okay, 1587. Which one is smaller? I'm going to go with this one. Okay, this is 71. This is 68. So based on this, then AR23 is the best model. So the lowest AIC and BIC, the more negative in this case, is AR24. Okay, so okay, so let's so I just changed, I'm sorry, I hope I'm not confusing you, but here what I did is, since I already got from here that AR2 is the best, then I'm going to use this information to build my AD, the ADL, what is this? The ADL PQ starting from 2Q. And all that I need to decide is decide about the Q, because I have already decided about the P. And I started from big to small, so I have 4 and I have 3. And I'm comparing only these two models, right? And then based on the comparison, we found that the lowest between the ADL24 and ADL23 is simply the ADL24, so this is our model. We can also, this is another option to, and this is what is done in practice, is we can use Granger causality test or the F test as follows. To check on the lags of X, right? And in our case, the lags of X or unemployment as follows. So we're going to regress starting from ADL to 4, okay? So we have like the large model, and we're going to test using F test. And it's confirming that there is a 0 probability that these lags are equal to 0, so the decision is keep it in the model. The 4 lags of D unemployment, Granger cause inflation. The best model is ADLPQ, so this is just confirming our results, okay? Okay, so this is just confirming our results using the information criteria statistic. Okay, you can also repeat this using sequential hypothesis test. How can I do that? So I'm going to do like a inflation like this. Let me show it to you. So you can actually perform a sequential hypothesis test. Let me have it in the green area. So this one and this one. This is the sequential, and this one. Okay. and the sequential hypothesis test, just when you run it, you will find, and again, you start from big to small, then you will find that it's basically confirming that the first one, when you just run the first one, you find it statistically significant. It's right here. So this is the big to small sequential hypothesis test. Just check the last leg. It's statistically significant, so you would stop and say, okay, even based on the sequential hypothesis test, even without doing a Granger causality F test, we can say that it is statistically significant on the fourth leg of unemployment, right? Next, one of the other reasons as of why we might have a series that is non-stationary is because of the presence of a break in the series. So by looking at the three graphs, I feel like inflation itself has a break. So again, I have the graph here of inflation, just to have it again. As you can see, there might be a break in the series right here, okay? So we need to check whether there is a break in the data set or not. The break might be related to a mistake in your inclusion of the data set, or your importing of the data set, you did some mistake, or it could be because of the change in economic policy. If it is the first one, which is your mistake, then just go ahead and, of course, correct your data set. If it is related to a change in policy, and you need to have this included in your model, of course, then you need to create a dummy for this break. So it is very important to determine when is the break. By just looking at the graph, and actually you can open the data set and you look at where is the biggest jump in the data set, you would be able to determine that this data set, this break happens starting in the fourth quarter of 1981. So what you need to do is to generate a dummy for this break. And it's simply a dummy variable that is going to take 1 for any time that is greater than 1981 quarter 3, because we can see that the break happens in the fourth quarter of 1981. Okay. If this is a question in an exam, then I would tell you when is the break happening. If there is a break, check if there is a break in the fourth quarter of 1981. Because there is another, in a more advanced course, you can, or if we have time, I can show you this, you can actually perform a loop that would go through the data set of inflation and try to determine when is the break happening. But for now, just by looking at the graph, we can see that this break happens around the fourth quarter of 1981. So anytime starting from the fourth quarter of 1981 onwards, we will give it a 1, a dummy equal to 1. And this dummy, we're just going to call it a break. Okay, so we generate this dummy variable this way. Okay. And if I include a dummy, it would only affect the intercept of the model ADL2Q. However, to be complete, like to change the whole regression, we also need to add interaction terms to change the slopes as well. So we create also interaction terms between each and every x in the model. I have a model that has 2 lags of the first difference in inflation and 4 lags of the first difference of unemployment. So I would create an interaction of this dummy with everything, all the x's in this model, so that we guarantee that we are changing the whole regression and testing whether it's significantly important or not. So let's generate the break and the interaction terms. And let's include them in our ADL2Q, 2-4. And this is the way of including them. So we have it here, okay? And we perform the Chow test which is the Chow test is simply actually, let me see. So this is our ADL 2, sorry, let me see. This is 2, ADL2, 4. Okay, these are the I don't see the break itself, just a second. So this is the interactions. I don't see the break itself, so let me include this. So this is in order to have a change in intercept and slope, and then we perform the test on the intercept break and the slope. Okay, so let's do this. So we do the regression and we do the test. And as we can see, there is a 0 probability that these are equal to 0. In other words, the break is important. So anytime I'm estimating this model, I need to take this break into my consideration because it's affecting the relationship between lags of inflation, lags of unemployment, right? And the prediction of the changes in inflation. So the Chow test is simply an F test on the presence of the break. In other words, we're doing it on the break, the dummy itself, and the interaction term. It's confirming that we need to have a dummy to capture the effect of the break. Okay? All right, so I'm gonna stop here and let me know if you have any question by posting your questions on the discussion forum.